Hello friends, so this is the part 2 for the questions from the year 2022, and there are total of 25 questions, and all these questions are from the mains. The part 1 we have already solved the advanced as well as some of the mains question which were from the year 2022. So this particular part 2 we are only going to solve the questions from the mains. So the first question, and it states that a light wave traveling linearly in a medium of dielectric constant 4 incident on a horizontal interface separating medium with air. The angle of incidence for which the total intensity of incident wave will be reflected back into the same medium will be given that relative permeability of the medium, that is mu of r, is equal to 1. So this particular question, it is associated with the total internal reflection, and here the refractive index of the material is not given directly. It is given in terms of the dielectric constant, that is our epsilon is given to us, and we are also given its relative permeability, that is given as to 1. So from here we are going to find out what will be our refractive refractive index for the medium. Okay. So we can say that refractive index of medium, that is suppose given as n, and it will be a product of our dielectric constant, that is our epsilon of r, and relative permeability, that is our mu of r. Mu of r is given to us 1, so we can say our reflective index, that is n, is equal to square root of 4 multiplied by 1. This gives us the value of n, that is our refractive index, is equal to 2. So we found out that is our reflective angle. And for total internal reflection, we are only interested in our critical angle. Therefore, we can write that for critical angle theta c, using Snell's law, we can write that our, let us call this as, okay, we can do it later on, no problem. So we can write this is n1 sine of theta 1 will be equal to n2 and sine of 90, because for total internal reflection the angle of refraction is equal to 90, and our n2 is our air, and this comes as 1 multiplied by 1, so will be equal to 1, and here n1 is nothing but our refractive index of the medium, so these two are the same quantities. Therefore we can write that our 2 sine of theta 1 will be equal to 1, which gives us that theta 1 is equal to sine inverse of 1 by 2, and this comes as 30 degree. Okay. And here let me write this is our critical angle, that is theta c, not theta 1. So we got our critical angle is equal to 30 degree, equal to 30 degree. But for total internal reflection, the angle of incidence should be greater than the critical angle. So you can say for total internal reflection incident angle should be greater than our critical angle. Incident angle, if represented as I, so we can write that our I should be greater than theta C, or which gives us that I should be greater than our 30 degree. So it means it is strictly greater than 30 degree. So option number 4, that is 60 degree, will be the correct option. Or you can say option 4 is correct. Next question, and it states that the difference in the speed of light in the two media A and B, that is VA minus VB, is 2.6 into 10 to the power 7 meter per second. If the refractive index of the medium B is 1.47, then the ratio of refractive index of medium B to the medium A is, given the speed of the vacuum, speed of light in the vacuum is 3 into 10 to the power 8 meter per second. So here we have to find out the ratio of the refractive index of the medium B to medium A. And in order to find out the refractive index of medium B, so we can say, let us say that a refractive index of medium A, let us given as mu of A, and refractive index of medium B is given as mu of B, and we are supposed to find out mu of B to mu of A. The ratio we have to find out, and we know the relationship between, you can say, the refractive indexes and the velocity within that particular medium. So for that, if we say that velocity in medium A, let us suppose, is given as VA, and velocity in medium B is, let us suppose, given as VB, therefore we can write that our refractive index B upon A will be equal to, this will be coming as VA upon VB. So it means we need to find out our VA and VB, and we also know that velocity in eddy medium is equal to, you can say, their speed of light in the vacuum divided by their respective refractive index. Okay. And for medium B, we are already given its refractive index, so therefore we can find out V of B. So we can write that our V of B will be equal to C divided by mu of B, and C is our 3 into 10 to the power 8, and mu of B is 1.47, and this will be coming as close to 20.4 into 10 to the power 7 meter per second. Now we can find out our V of A, because we are given that V of A minus V of B is equal to 2.6 into 10 to the power 7. So we can say V of A will be equal to 20.4 plus 2.6 into 10 to the power 7. So from here we get V of A is equal to, this will be coming as 23 into 10 to the power 7 meter per second. So we got our V of A and V of B. Therefore, we can write our ratio that mu of B upon mu of A is refractive index of B, refractive index of A. The ratio will be equal to 23 into 10 to the power 7, and this is 20.4 into 10 to the power 7, and this ratio is approximately equal to 1.13. So therefore, the option number C is the correct one. Option C is correct. Next question. We are given a light whose electric field vectors are completely removed by using a good Polaroid allowed to incident on a surface of prism at Brewster angle. Choose the most suitable option for the phenomena related to the prism. Okay, so we have to find out which of these option will be correct one. Okay, so it is basically, you can say, reflected, refracted, and the wave propagation are the, and one of the is the total internal reflection. So here we are given that the electric field vectors are completely polarized by using a good Polaroid, and it says that it is incident on a Brewster angle. Okay, so we can just draw an approximate figure for that, and so here let us suppose we have incident light, something like this, and it is partially reflected and it is partially refracted. Okay, and the angle, it is Brewster, you can say, therefore the angle between the refracted and the reflected ray will be 90 degree. And so incident, let us suppose it is having, because it is a ordinary light, and refracted will be partially polarized and the reflected will be the polarized one. Something like this, we can just draw an approximate figure for that. So this is our incident, light, and this will be our refracted, and it will be partially polarized, and this is our reflected, and it is completely polarized. And it says that only the electric field vectors of the incident are completely removed. So it means there will be no reflections and there will be total transmission of light through the prism. So because this is, you can say that incident light, the electric field vectors are completely removed, so there will be no reflection and total transmission. So no reflection and total transmission. And therefore option D is the most suitable one. You can say option D is the correct one, because here in the question you can say the direction of polarization as such is not mentioned. So the only best option that is related to this discussion is option number D. D is correct. Next question. It states that a light ray is incident at an angle theta 1 on the system of two planes, mirrors M1 and M2, having an inclination angle 75 degree between them, as shown in the figure. After reflecting from mirror M1, it gets reflected back by the mirror M2 with the angle of reflection 30 degree. The total deviation of the ray will be. So we have to find out here the total deviation of the ray. Therefore, we can say that we are given that the incident is at angle of theta 1 and first on the mirror M1, and then it will be from the mirror M2, and the deflection is given at an angle of 30 degree. So we can just draw an approximate figure for that, and you can say that we have two mirrors which is having angle of inclination of 75, and a light is incident. So this is our M1 and we have our M2. Light is incident, suppose somewhere here like this, okay. And if we can draw a normal which will be coming something like this, so it will be reflected toward the M2, and for M2, let me draw this again. So we have incident light and this is a normal, and it will be reflected, suppose from this point in this direction, so it will be something like this. Hopefully it is not something like this. And so we are given the angle of inclination is our 75. So therefore we can say that we have a angle, this is theta 1, this angle will be also a theta 1, and we are given that with angle of reflection 30 degree. Okay, so here we are given 30 degree, so this angle will be also 30, and so we can find out that these two angles will be equal and they will be each is equal to 45 degree. Similarly, you can say these two angles, this will be about 60 and this will be also about 60. So we can just find out all these angles, and we need to find out our, you can say, the total deviation of the ray. And for the total deviation, you can say there are total will be equal to, we can just use the formula, that is standard formula, that is deviation of the total will be equal to 360, and we have twice of theta, and theta is 75, so we get this as 360 minus 2 into 75. This gives us total deviation will be 210 degree. This will be our total deviation, and we can also draw this figure. So here we are going to have two deviation. One will be in this direction and another one will be in this direction. So both the deviations are along the same way. Okay. And we can just add these two deviation, and that will become also coming as 2 under 10. If you want to solve it that way, we can also sort it out. Okay. Next question. One second. I think this is this gives us 210 degree, and if we require do we need to solve it otherwise also? One second. I think this will work. Not much of the thing is required here, because if we need to find out, so this total angle will be our 120, and this angle will be our 90, and here the total deviation will be, once again, if you want to find out with respect to angles, that will be also coming as 90 plus 120, giving us 210. We can just, because we have this 60 and this is also 60, so total 180, and so we are going to get this as 120, I think. Yeah, so this is good. Next question. Here it states that a small bulb is placed at the bottom of a tank containing a water to the depth of square root of 7 meter. The refractive index of the water is 4/3. The area of the surface of water through which the light from the bulb can emerge is x by meter square. The value of x is, so here we are given that is a bulb is placed in a, you can say, inside a tank. Okay, and water depth is given to us, so we can just draw an approximate figure for that. And let us suppose this is our tank and water, and we have a bulb that is placed at the bottom somewhere here, and it says that the area of surface of water through which light from the bulb emerges out. So the light of the bulb emergence is given by some area, so this is the area given to us, and obviously we are here, because this is our A point and let us suppose this is B point. So the point A and B, the only light will be merging between these 2 points A and B, such that after point B we are going to have a total internal reflection. Okay, so this is the basic premise for that. And if we can just draw one side of it, we can sort it out for the other also. So let me say that this is point B and this is normal, so this angle will be a critical angle, and let us suppose this is the center of this part, and obviously this angle will be also our critical angle, and the height is given to us. Let us suppose that is h, and refractive index is given, so this portion will be our radius of this, so this will be our radius r. So from here we can say this is height over h. So from here we can say our tangent of C will be equal to r upon h, or we can say our r is equal to h tangent of C. And for critical angle, that is sine of C is equal to 1 upon refractive index. So we know for critical angle 1 upon C is equal to 1 upon refractive index, and refractive index is given to us as 4 by 3, so this comes as 3 by 4. So from here we can say our tangent of C will be equal to 3 square root of 7. So now we can easily substitute the value and we get that our r height is given to us as square root of 7. So this comes as square root of 7 multiplied by 3 and square root of 7. Here square root of 7 cancels out, and this comes the radius is equal to 3. So the area of the surface will be equal to pi r square, that is coming as 9 pi, and we are given that this is equal to x pi. So from here we can say our value of x is equal to 9. So value of x is equal to 9. Next question. And it states that consider a light ray traveling in air is incident into a medium of refractive index square root of 2 times n. The incident angle is twice that of refracting angle, then the angle of incidence will be. Okay, so it says that the light ray is traveling in air is incident into a medium of refractive index square root of 2 times n. So we can just draw an approximate figure for that. So this is air and this is normal. So let us suppose angle of incident is I, and we are given that the angle of refraction is twice that of the incident angle. Okay, so let us suppose this is our refracting angle, that is r, and its refractive index is given as square root of 2 times n, and we have air, so here refractive index will be 1. So this is our air and this is our medium, and we are given that incident angle, that is I, is equal to twice of r, and let us suppose we have this as mu1 and this value is mu2, and this is point over A. So we can use Snell's law at point A. Snell's law at A, we can write this as mu1 sine of I is equal to mu2 sine of R. mu1 is our 1 and I is equal to twice of R. And we have to find out the angle of incidence, so we can say that our R is equal to I by 2. Therefore, we substitute it. mu1 is our 1 and we have sine of I, and mu2 is given as square root of 2 times n, and here we get as sine of I by 2. Therefore, we get this as that square root of 2n is equal to sine of I and is sine of I by 2, and we can use half angle, so this will be 2 sine of I by 2, and we have cos of I by 2 divided by sine of I by 2. This sine of I by 2 and sine of I by 2 cancels out, so we are left with that 2 cos of I by 2. And we can write it as that cos of I by 2 will be equal to, and this comes as square root of 2n divided by 2, giving us square root of n divided by 2. So we can write this as our I upon 2 will be equal to cos inverse square root of n divided by 2. Okay, this is complete square here also and here also. Everything is good now. Therefore, we can write that our angle of incidence, that is I, is equal to 2 cos inverse of square root of n divided by 2. So this is our angle of incidence, and option number D is the correct one. Option D is correct. Next question. Here we are given that a convex lens of power P is cut into two halves along its principal axis. Further, one piece out of two halves is cut into two halves perpendicular to the principal axis as shown in the figure. Choose the incorrect option for the reported pieces. So we are given this figure. So first, the lens is cut in two halves along this axis. So it will be giving us two halves. Sorry, not this axis. First, it is cut along the principal axis. Okay, so along the principal axis means it is cut in this way. So this is going to give us, this is the first lens and this will have a second lens. Okay. Then one of the lenses is cut perpendicular to the principal axis. So it means, suppose this lens is cut in two halves, and therefore from here we are going to get these two lenses. Okay. And so when they are cut in, you can say perpendicularly. So let us suppose this power is P1 and that is its power is suppose P, so this will be also equal to P, and let us suppose this is our P1 prime and this P1 prime will be also equal to P. But when it is cut into perpendicularly, So we can say this is our P2 for L2. This will be coming as P by 2, and our L3, let us suppose that is P3, that will be also coming as P by 2. So L1 is going to have P1, which is equal to P. So these are the respective powers, and we have to find out here incorrect one. And the incorrect one is that power of L1 is equal to P. So therefore you can say option number A is the correct one, okay, because we have to choose the incorrect one. You can say option A is correct. Next question, and it states that the refracting angle of a prism A and the refractive index of the material of the prism is cot A by 2. Then the angle of minimum deviation will be equal to, and here we are given that we have a prism. So let us draw an approximate figure for that. And the prism angle is given as A. So let us suppose this is prism angle A, and the angle of minimum deviation we have to find out, and the refractive index of this material is suppose given as mu, and that is equal to cot of A by 2. And we have to find out for minimum deviation, and that is directly based on the formula, and the formula states that and the formula states that we have refractive index mu will be equal to sine of A plus lambda m divided by 2, and this is sine of A by 2, where lambda m is the minimum deviation. Okay. We can say our lambda m is minimum deviation. And mu is given to us cot of A. So we can substitute it. We can write this as mu is equal to it is A by 2 will be equal to, we can write cot is equal to cos A by 2. We can write this will be equal to cos A by 2 sin A by 2 is equal to sine of A plus delta m divided by 2, and here we have sine of A by 2, and this sine A by 2 cancel out, so we get this as sine of A plus delta m divided by 2 is equal to cos of A by 2. And we can write this cos of A by 2 will be equal to 90 minus, with respect to angle, we can write this as sine of 90 minus A by 2. So this gives us that A plus delta m divided by 2 is equal to 90 minus A by 2, which gives us that A plus delta m will be equal to 180 minus of A, and this gives us that delta of m will be equal to 180 minus 2 of A. So this is the angle of minimum deviation, and option number A is the correct one. option A is correct. Next question. We are given that the aperture of objective is 24.4 centimeter. The resolving power of this telescope, if a light of wavelength 440 angstrom is used to see the object, will be. So we have to find out the resolving power, and here we are given that the aperture is given to us 24.4 centimeters. So aperture, if represented as capital D, so we are given this as 24.4, and we can just write into minus 2 meters. So this will be 0.244 meters. And wavelength is given to us, lambda, that is our 2440 into 10 raised to power, you can say this will be equal to angstrom, so this will be 10 raised to power minus 10 meters. And so our resolving power, we already know the formula, so we can say that resolving power is given as capital D divided by 1.22 times lambda. So we simply substitute the value. We have this as 0.2244, and this is 1.22 multiplied by lambda, that is 44 into 10 raised to power minus 10. And the resolving power will be coming approximately as 8.2 into 10 raised to power 5. So we have 8.2, sorry, here it has to be multiplied everywhere. So option number C is the correct one. Option C is correct. Next question. We are given a parallel beam of light is allowed to fall on a transparent spherical globe of diameter 30 centimeter and refractive index 1.5. The distance from the center of the globe at which the beam of light can converge is. So we are given a globe, and so we can just draw an approximate figure for that. So let us suppose this is a globe, and this is our principal axis for the light. We are given a center, so let us put this here center, two ends, one end is our A and another end is our B, and this we can, ray of light is coming parallel. Suppose it is coming in this way, so there will be two surfaces. Let us call this as surface 1 and this as surface 2, and we are given that the diameter is 30 centimeter. So this is our 30 centimeter, and refractive index is given to us as 1.5. Okay, so it means first of all parallel beam is going to strike the surface 1, and then the image found by the surface 1 will be acting as an object for the surface 2. Okay, and therefore we can find out the required convergence after the surface 2. So we are given that lights are coming parallel, therefore we can say our U u, that our object is at infinity, and we can find out our radius of curvature. Radius is our diameter is 30, so radius of curvature will be coming as 15 centimeter, and we can use the formula that the refraction at the surface 1 refraction at surface 1, and the formula is our mu2 upon v minus mu1 upon u is equal to mu2 minus mu1 upon r. And here we have to remember that mu1 is our incident surface, so refractive index for incident part, so this will be a mu1 and this will be a mu2. And we substitute the values. We can write this as mu2 is given to us as 1.5, so this comes as 1.5. Let us call this as v1 minus 1 upon infinity, and this is our 1.5 minus 1 and divided by plus 15. We can just write it minus infinity also, doesn't matter. And from here we can find out our v, and this v will be, rather we can say v1, this will be coming as plus 45 centimeters. So the surface 1 will be forming an image that will be somewhere here, because this is 30, so this is our, let us suppose, our I1. So if required we can just, so this will be our perpendicular and it will be refracting, and it is going to converge first time somewhere here, and similarly for the bottom side also. And now this you can say I1 will be acting as an object for surface 2. So you can say that our I1 will act as an object for surface 2. And here we are coming as 40, so this distance will be our 40. And for surface 2 we are only interested in this part, so we can, this 40 minus 30 will be giving us 10. So for surface 2 the I1 will be acting as an object, therefore we can say that our U1 will be equal to our 10, and radius of curvature will be equal to minus of 15. And we can substitute the values, and using the same formula we are going to get this as mu2 upon v minus mu1 upon u is equal to mu2 minus mu1 upon r, and let us call this as 2, and this is our 1. Therefore we get this as 1 upon v2 minus 1.5 upon 10 is equal to, this will be coming as 1 minus 1.5 divided by minus of 15. Okay. And let me, okay, this no problem. So therefore we can say that our V2 will be equal to 7.5 centimeters. So it means the refraction will be, and this will be from pole B, so ray of light will be bending something like this, and this will be our I2. So this is corresponding to our I2, and we have to find out the distance from the center. Okay, so distance from the center will be equal to 15 plus 7.5. So you can see distance from center will be equal to 15 plus 7.5, and this will be coming as 22.5 centimeters, and the answer is asked in millimeters, so we can say this will be equal to 225 millimeters. So this will be over 225 millimeters from the center of the sphere. Next question. It states that the speed of light in the media A and B are 2 into 10 to the power 10 centimeters per second and 1.5 into 10 to the power 10 centimeter per second respectively. A ray of light enters from the medium B to A at an angle of incidence theta. If the ray suffers total internal reflection, then so we have to find out the value of theta if the ray is going to suffer a total internal reflection. And here we are not given the refractive indexes, but we are given the speed of the light in both media A as well as media B. And it says that light enters from media B to media A. Okay. So therefore we can draw an approximate figure for that. Let us suppose this is our media B. So this is our media B and this is our media A. And light enters from media A, so media A to media B, and suffers total internal reflection, so it doesn't enter the media A. And let us suppose, so obviously this angle will be a critical angle. Let us call this a critical angle as theta C. And we know that for total internal reflection, the angle of incidence should be greater than the angle, here it is the angle of incidence given theta. Okay, so critical angle is of theta C. So let us say that our critical angle is our theta C, and it is said that the angle of incidence is theta. Therefore we can say for total internal reflection, our theta should be greater than the critical angle. So we are mainly interested in finding out theta C, and for this critical angle we can say that our sine of this critical angle will be equal to our ratio of their refractive indexes, and we can say that velocity of medium A, sorry, not A but B, divided by velocity of medium A. And this in terms of refractive index we want to write, so we can say this will be our mu A upon mu B. Okay, but we are given the velocities, so we can just write in the form of the velocity. So this is our velocity in medium B, velocity in medium A, refractive index mu B, and refractive index in medium A. So we substitute the values, we get this as VB is given to us as 1.5. So we have this as 1.5 into 10 is power 10 and 2 into 10 is power 10. And this comes as 10 and 10 goes away. So this becomes 15 by 20, and 15 by 20 can be written as 3 by 4. 3 by 4. Therefore, we get our theta C will be equal to sine inverse of 3 by 4. And for total internal reflection, we know that our angle of incidence at theta should be greater than theta C. So we substitute value of theta C rather. So we get our, for total internal reflection, we should be having theta is greater than theta C, or we can say our theta is greater than sine inverse of 3 by 4. Therefore, theta is greater than sine inverse of 3 by 4. Option number D is the correct one. Option D is correct. Next question. And it states that for an object placed at a distance of 2.4 meter from the lens, a sharp focused image is observed on the screen placed at a distance of 12 centimeter from the lens. A glass plate of refractive index 1.5 and thickness 1 centimeter is introduced between the lens and the screen such that the glass plate faces parallel to the screen. By what distance should the object be shifted so that a sharp focused image is observed again on the screen? So here we can just draw an approximate figure. So we are given a lens. So this is our lens, and this is suppose a principal axis, and we have given a screen. And the distance between the lens and the screen is about 12 meter. So this distance is given as 12 meter to us, and we have object O. This is given as 2.4 meters, and the screen is introduced between the two. And screen is introduced. Let us suppose this is our screen, and its thickness is given as 1 meter, and we have to find out the object is to be shifted. So once again we get a sharp focused image on the screen. It means the position of the image will be fixed, whether with the screen or without the screen. The position of the image has to be same. And introduction of this sheet is going to, you can say, result in the shift that we can easily find out. So first of all, we are going to find out the focal length of the lens, and for that we can use the formula that for lens we have 1 upon f is equal to 1 upon V minus 1 upon U, and U is our 2.4 but negative, and V is our, you can say, positive, that is given as 12 centimeter. So this comes 1 upon 12 minus, and 2.4 meter is given to us. So we can just write it in centimeters. That will be coming as 1 upon 240. And we can sort it out, and this will be coming as 240, and we get the LCM will be equal to 20, and this is minus, so this will be giving a plus 1. Therefore the focal length will be equal to 240 divided by 21 centimeters. And because of the introduction of this slab glass plate, there will be shift introduced. You can say for glass plate, a shift is produced, and that shift we can easily find out. So we can say our shift, if given as S, that will be equal to thickness and 1 minus 1 upon refractive index. So this is given as 1, we have 1 minus 1 upon 1.5. So we get this shift will be equal to 1.1 by 3 centimeters. Okay. So it means from here we need that once again the image should be always on the film. Okay. So it means if you want that for the image to be on film, the lens should form an image at a distance. The lens should form an image at distance let us suppose that distance is given as V prime, then this V prime will be equal to, the original distance was our 12, so this comes 12 minus the shift, that is 1 by 3, and this comes as 35 by 3 centimeters. So once again, based on this new position of the image, that is V prime, we are going to find out the new position of the object. Therefore we can say our 1 upon F is equal to 1 upon V minus 1 upon U. So this is V prime and U prime, and we are interested in our U prime, so we get this as 1 upon U prime will be equal to, focal length we found out is 21 upon 240, and this is our minus plus 1 upon V prime, that comes as 3 by 35, and from here we get that our V prime, or sorry, this will be equal to minus 3 upon 1680. So we get our u prime. We can easily cancel out this and it will be coming close to as 560 centimeter. So we can say u prime is equal to minus of 560 centimeters, and we can write this as minus 5.6 times meters, and here we are interested in magnitude only. So we can say our u prime magnitude will be equal to 5.6 meters. So therefore the shift of the object will be equal to the new position, and the original position was about 2.4, so this comes as 3.2 meters. So this is the shift of the object, that is 3.2 meters. So option number B is the correct one. Option B is correct. Next question. And it states that a convex lens of focal length 20 cm is placed in front of a concave mirror with principal axes coinciding each other. The distance between the lens and the mirror is 10 cm. A point object is placed on the principal axis at a distance of 60 cm from the convex lens. The image formed by the combination coincides the object itself. The focal length of the convex mirror is, so we have to find out the focal length of the convex mirror, and it states that the image formed of the entire combination means that for the convex lens and concave mirror is be coinciding with the object itself, and this is only possible that if the ray of light is able to retrace its path. So we can just draw an approximate figure. So this is our lens, principal axis, and we have a mirror, and we have an object distance is given as 60, and this is a lens and this is a mirror. So ray of light first will be refracted by the lens and it should be falling perpendicular to the mirror, something like this, at an angle of 90 degree, and obviously it has to be passed through the center of curvature for the this mirror. So this will be center of curvature and it is about 20 centimeters, and the distance between the two is given to us as 10 centimeter. It's given 10 centimeter. Okay. So radius of curvature is not given to us. Sorry, my mistake. And first of all, we are going to find out the position of the image because of the lens. So we can say for lens, we can use the formula 1 upon V minus 1 upon U is equal to 1 upon F, and our U is our minus of 60, and the focal length is given to us to be 20. Therefore, we can write that 1 upon V will be equal to, this comes as 1 upon F plus 1 upon U, and we have this as 1 upon 20. This is minus 1 upon 60. So we get our V will be equal to 30 centimeters. So the position of the image will be at a distance of 30 centimeter, and obviously if it's at a perpendicular ray of light, when striking a mirror at a perpendicular, it has to pass through center of curvature. So it means if this is the, let us suppose, of I1, so the image I1 will be at the center of curvature, that is our C. So we already found out this distance is our 30 centimeter. And therefore we can find out the radius of curvature of the mirror, that will be 30 minus 10. So we can say the final image coincides with object. Therefore you can say after refraction from lens, after refraction from lens, the ray is perpendicular to the mirror and passes through the center of curvature. Center of curvature. Therefore, I1 image is formed at center of curvature. So based on this, we can find out that the radius of curvature will be equal to 30 minus 10, giving us 20 centimeters. So from here we can find out the focal length of the mirror. Focal length of mirror will be equal to our half of the radius of curvature, that is equal to 10 centimeters. And we are only finding the focal and convex mirror, that we got as 10 centimeters. So this is our 10 centimeters. Next question. We are given the graph between 1 by u and 1 by v for a thin convex lens. In order to determine its focal length is plotted as shown in the figure. The refractive index of the lens is 1.6 and its both surfaces have same radius of curvature r. The value of r will be in centimeters, and use the object distance and v is the image distance. So we are given this particular figure, and here two points are important. One is our point A and another one is point B. This x-axis, which is in negative, is given as 1 by u, and the y-axis, which is in positive, is given as 1 by v. So we consider any one point. Let us suppose we consider point B. You can say at point B, we can write that our 1 by u will be equal to minus of 0.1 centimeter, and obviously at this point B, our 1 upon v will be equal to 0. And from here we can write that our u will be equal to minus of 10 centimeter and our v will be equal to infinity. And this is for our convex lens, and therefore we can say that our focal length, so we can use the formula for lens we have 1 upon f is equal to 1 upon u minus 1 upon v. So this comes as, sorry, I wrote 1 upon v minus 1 upon u. And this comes as 0, minus and minus of this will be coming as 1 upon 10, giving us focal length is equal to 10 centimeters. And we are given that they have the same radius of curvature. So one will be our plus r and other will be our minus r. So we can use the formula that our 1 upon f is equal to mu minus 1, and we have this is 1 upon r1 minus 1 upon r2. Here our r1 is equal to plus of r and r2 is equal to minus of r. So we need to find out radius curvature. Focal length we just found out. So this will be coming as 1 upon 10 is equal to 1.5 minus 1. This is 1 upon r plus 1 upon r. So this gives us that our 1.5 minus 1 will be 0.5. So we have 1 upon 10 is equal to 0.5 multiplied by 2 upon r. Therefore, we can say that our r, radius of curvature, will be coming as, you can say this will be our 10 and 10 and 10 goes away and this comes 10, so r will be our 10 centimeters. So we found out our radius of curvature will be equal to 10 centimeters. Next question. It says that light travels in two medii m1 and m2 with a speed of 1.5 into 10 to the power 8 and 2 into 10 to the power 8 meter per second respectively. The critical angle between them is equal to. So for critical angle, you can just draw an approximate figure. So let us suppose this is our incident ray. So with this will be our denser medium and this will be our rarer medium, and for critical angle the angle of refraction will be our 90 degree, and let us call this a critical angle as theta c. And we are given that the respective velocities are given, and we know the relationship between the velocity in any medium, that is v, is equal to c upon the refractive index of that medium. And let us suppose this is our point A. So we can say Snell's law at A, we can write that refractive index of denser medium sine of theta c will be equal to refractive index of rarer medium, and this we get as sine of 90. So denser medium is having n of d, rarer medium is having n of r. So we can say from here that our sine of theta c will be equal to sine 90 is 1, and this comes as refractive index of rarer medium, refractive index of the denser medium. In terms of velocity in the particular medium, we can use this expression. So from here we can see that our velocity is in a medium is inversely proportional to the refractive index. So therefore we can write this as velocity in the denser medium and velocity in the rarer medium. The values are given to us. This is 1.5 into 10 to the power 8, and here we have 2 into 10 to the power 8, and this is our 3 by 4. Therefore our sine of theta c will be equal to 3 by 4. But from here we can say our theta c is equal to sine inverse of 3 by 4. But the only option sine is sine inverse of 2 by 3. Okay, which is incorrect. So we have to convert into tangent and find out the correct option. Therefore, we can say that tangent of theta c will be equal to over 3 divided by 4 square minus 3 square and its square root, which gives us a 3 square root of 7. Therefore, theta c is equal to tangent inverse of 3 square root of 7. So the option number A is the correct one. Option A is correct. Come to the next question. And it states that in the given figure, the face AC of a equilateral prism is immersed in liquid of a refractive index n. For an incident angle 60 at the side AC, the refracted light beam just grazes along the face AC. The refractive index of the liquid, that is n, is given as square root of x divided by 4. The value of x is given that the refractive index of glass is 1.5. So we are given this particular figure, and the face AC is having a liquid and ray is incident at an angle of 60 degree on the face AC, and we are given the refractive index of the prism is given as 1.5 and of that liquid is given as n. Okay, and we have to find out the value of n. You can say this particular n. Let us call this point as O. So if we use Snell's law at O, we can write that our mu sine of 60 is equal to, and we have this as n, and sine of 90. Mu is 1.5, so we can write this as 1.5 sine 60 is square root of 3 divided by 2. Sine 90 is 1, so this becomes n. And n is given to us as square root of x divided by 4. So this will be square root of x divided by 4. And we can just solve it now. We get this as our n, not n, we are required to find out the x. So we can say square root of x will be equal to, we have this as 1.5, and we can just cancel out, this goes by 2, and we get this 1.5 multiplied by 2 and multiplied by square root of 3, and this comes as 3 square root of 3. So value of x will be equal to, we can just square both sides, this comes as 27. So value of x is our 27. Next question. We are given that a microscope was initially placed in air, refractive index 1. It is then immersed in oil, refractive index 2. For a light whose wavelength in the air is lambda, calculate the change in the microscopic resolving power due to oil, and those and choose the correct option. So we have to find out the resolving power and with respect to a comparison between the oil and the air. And we know the you can say the relationship between the resolving power and the you can say for a microscope, and that is standard formula which states that resolving power, let us suppose first of all let's sort it out for air. Resolving power for first we have our air, and we can write this as resolving power air will be equal to 2 sine of theta divided by 1.22 times lambda. And then we have our oil, and let us call this as resolving power oil, which will be equal to 2 sine of theta, and this is 1.22 lambda of the oil. But the wavelength that is given to us is for only our air, so we can say our lambda of oil will be equal to lambda divided by refractive index of the air, which is 1. So we can just modify the formula. So we get this as 2 sine of theta is 1.22 into lambda, and this comes multiplied by mu. So we find out the ratio, and the ratio we get is our resolving power of this is nothing but resolving power of the air. So we get resolving power of the oil will be equal to resolving power of air multiplied by refractive index, that is given as 2. So therefore we can say that the resolving power is twice in oil than that of the air. So option number B is the correct one. Option B is correct. Next question, and it states that a thin prism of angle 6 degree, refractive index for yellow, that is n of y is 1.5, is combined with another prism of angle 5 degree and refractive index of yellow is given as 1.55. The combination produces no dispersion. The net average deviation, that is delta, produced by the combination is 1 upon x. Then the value of x is equal to. So we have two prisms, P1 and P2, and net deviation is given as delta. So this delta will be equal to deviation because of the P1 and deviation because of the P2, that is their algebraic sum. So we can write that your deviation delta will be equal to deviation because of the P1 and deviation because of the prism P2. And we have standard formula that deviation is equal to refractive index minus 1 and multiplied by the angle of prism. So therefore we can write mu1 minus 1 and multiply by a1 minus, and here we have our mu2 minus 1 multiplied by a2. So we can substitute the values. Mu1 is given to us as 1.5, minus 1, and a1 is given to as 6, this is a minus, and mu2 is given as 1.5 5 5 minus 1, and our angle is given as 5. So this will be equal to, this comes as 3 minus 2.75. So we get that our deviation will be equal to, this will be coming as 3, this will be 0.25, and in terms of the friction this will be coming as 25 on 100, that is equal to 1 by 4, and which is given as 1 by x. So we can say that our x is equal to 4. So value of x is given to us, comes out as 4. Next question. It states that, as shown in the figure, after passing through medium 1, the speed of light v2 in medium 2 will be, okay, and c is given to us. So we have to find out the speed of the light after passing medium 1. Speed of light after passing medium 2, that is our v2 we need to find out. And this is, you can say, because we already know the relationship between the refractive index and their speed, and here we have respective mediums. So this is our, for medium 2, okay, let me write the formula. So you can say for medium 2, you can write this as refractive index, let us suppose, is given as mu2, and we have to do it in a relative way, not this way. So we know the formula that refractive index of a medium divided by refractive index for air is inversely proportional to the speed of the light in air, that is c, and velocity in the medium of reference 2 is our mu2. And this mu2 we can write, because we know that our mu is equal to c upon v. This is a standard formula. So we can see from here that the refractive index and the velocities are inverse of each other, and mu2 can be written in terms of the relative permeability and their mu r. So we can write this as mu r2 multiplied by epsilon r2 and its square root, and mu of air is equal to c upon v2. So we substitute the values. We are given mu r2 is our 1, and er is given as 9 square root, and refractive index of our air is our 1, and this comes as c upon v2. C is also given to us. C is our 3 into 10 to the power 8, and square root of 9 will be coming as 3. So we can say our v2 will be equal to 3 into 10 to the power 8 divided by 3. 3 and 3 goes away. So we get our v2 is equal to 1 into 10 to the power 8 meter per second. So option number A is the correct one. Option A is correct. Next question. We are given in normal adjustment for a refracting telescope, the distance between the objective and eyepiece is 30 centimeter. The focal length of the objective when the angular magnification of the telescope is 2 will be equal to. And here it is given for normal adjustment, and the distance between the object and eyepiece is about 30 centimeter. So from here we can say that summation of focal length of the eyepiece as well as objective length will be equal to 30 centimeter. We can say focal length of objective, focal length of eyepiece will be equal to 30 centimeter, and magnification we know is our f naught upon fe, and that is given as 2. So this will be equal to 2. From here we can write our f naught is equal to twice of fe. So we substitute and we get this as our f naught is equal to twice of fe. So we substitute, and or from here we have to find out the focal length of the objective. Okay, so what we do the reverse of it, and we can write that our fe is equal to f naught divided by 2. So we substitute it, we get this as our f naught plus f naught by 2 is equal to 30. So this gives us 3 f naught divided by 2 is equal to 30, and this will be 20. So f naught is equal to 20 centimeters. And okay, this was the required one. So we get option number A is the correct one. Option A is correct. Next question. We are given that power of the lens which is biconvex is 1.25 per meter in a particular medium. The refractive index of lens is 1.5 and radii of curvature is 20 centimeter and 40 centimeter respectively. The refractive index of the surrounding medium is. So we have to find out the refractive index of the surrounding medium, and this you can say is we are given the power. Okay, so we can use the formula which is our 1 upon f is equal to, this is mu1 minus mu2 divided by mu2 is equal to 1 upon r1 minus 1 upon r2. But we are given a power, and power is given to 1.5, so we can just reformulate this equation. Will be coming as mu2 upon f will be equal to mu1 minus mu2, and here we have 1 upon r1 minus 1 upon r2, and this particular is equal to our power. Therefore we can write that power is given to us as 1.25. So here we have 1.25 is equal to mu1 is our 1.5 minus mu2, and we are given as our r1 is our 0.2 and r2 is our minus of 0.4. So we come 2 plus 0.4, and 0.4 will be LCM, so this comes as 0.6. So we get this as 1.5 minus of mu2 will be equal to 1.25 multiplied by 1.25 LCM will be over 0.4, 0.4, 0.6. Okay, so this will be coming as 0.4 and it will be 0.6. Let me check. 0.4 is LCM. Yeah, this looks good. So you can say from here that our mu2 will be equal to 4/3. So the option is D is the correct one. Option D is the correct one. Is correct. Next question, and it states that an object O is placed at a distance of 100 cm in front of the concave mirror of radius of curvature 20 cm as shown in the figure. The object starts moving towards the mirror at a speed of 2 cm per second. The position of the image from the mirror after 10 seconds will be. So we are given this basic figure. Object is placed at a distance of that is given as 100 cm, and we have to find out the position of the image when the object has traveled for 10 seconds, and speed of the object is given to us as 2 centimeters. So here we can just find out the distance traveled by the object by using the formula that is S is equal to ut or D is equal to ut. You can say that distance traveled by object in 10 seconds. Let us suppose that is given as S. S will be equal to our speed, that is our 2 multiplied by 10. So this comes as 20 centimeters. Okay. So we can just draw an approximate figure. So this is our mirror, principal axis. Initially the object was here. Let us suppose this as O, and the distance is given to us as 100. And after 10 seconds it has moved a distance, let us suppose somewhere here, which is O prime, and this distance is about 20. So with respect to this mirror, the distance between the new position of the image, the object that is O prime, and the mirror is our 80. And we have to find out the position of the image. Okay, so now our u will be equal to minus of 80, and our focal length will be equal to half of the radius of curvature. The radius of curvature is given as 200 centimeters. So this will be over 200 divided by 2, coming as 100 centimeters. So now we can just use the straightforward formula, and this will be our minus, and we can use the formula that for mirror we can say that 1 upon V plus 1 upon U is equal to 1 upon F. So we get 1 upon V is equal to, we have this as minus 1 upon 100, and this will be plus 1 upon 80, and LCM will be, let us suppose, is over 8000. So this comes as 80, so this will be minus of 80 plus 100, and this comes as 20 upon 8000, which gives us by 400. Therefore, V position of the image is our 400 centimeters. So we have this as 400 centimeters. Next question. And it states that in an experiment with a convex lens, the plot of image V prime against the object distance V prime measured from the focus gives a curve V prime multiplied by U prime is equal to 225. If all the distances are measured in centimeter, the magnitude of the focal length of the lens is, you have to find out the focal length, and this is directly based on the Newton's formula, and which states that the product of the image distance and object distance will be equal to square of the focal length. So we have Newton's formula, which gives us f square will be equal to, we have this as V prime and U prime. So we substitute value, we get f square is equal to, given as 225, so focal length will be equal to 15 centimeters. So the correct option is, sorry, the answer is 15, no option is there. Next question. And here it states that the xy plane be taken as the boundary between two transparent media M1 and M2. M1 is Z1 greater than or equal to 0, has a refractive index of square root of 2. M2 is less than 0, has a refractive index of square root of 3. A ray of light traveling in M1 along the direction given by the vector A is incident on the plane of separation. The value of the difference between the angle of incident in M1 and the angle of refraction M2 will be. So we have to find out the difference in their angles of incident as well as the M2 refraction angle. Okay. So it means if you want to draw this figure in 2D, so angle of incident is in the medium M1 and the angle of refraction is in the medium M2. So we can just draw, so this is a medium M1 and this is medium M2, and the refractive index, let us suppose mu1 is given as square root of 2, and here refractive index of mu2 is given as square root of 3. Okay. And the incident is, let us suppose this is given as angle I, and this is our angle R, and this is an incident vector that is given as A. And okay, and we are given that M1 with respect to Z axis is Z greater than or equal to 0 and M2 is less than 0. Okay. So the division of the plane is with respect to Z axis. And let us suppose this is a point O, and therefore if you write the equation for Snell's law at point O, so we can say Snell's law at O, we can write this as mu1 sine of I is equal to mu2 sine of R. And here the angle of incident as well as the refraction will be with respect to the Z normal, which this normal is going to act as a Z axis. Okay, will be acting as a Z axis. So we can say that incident vector A makes eye angle with normal z axis and refracted angle, let us suppose this is vector called as r. So you can see refracted vector r makes r angle with normal z axis and or we can also say with the help of the direction cosines. With the help of direction cosines. So we can write that our I will be equal to cos inverse of A in the form of Z. Sorry, you can write this is our cos inverse of A of Z divided by A, which gives us cos inverse of A of Z. Vector A is given to us as 4 root 3i, 3 root 3j and phi of k. So our z, A of you can say the vector A in z direction, that is our 5 divided by the magnitude, and magnitude we can write this will be equal to 4 square root of 3 whole square plus 3 square root of 3 whole square, and this will be plus minus of 5 whole square and its square root. So we get that our I is equal to cos inverse of 5, and this will be coming as 10, which comes as 5 by 2, 1 by 2 rather. So we get I is equal to our 60 degree. So we found out our angle of incidence. Now we can easily find out the angle of refraction, because Snell's law is our mu1 I is equal to mu2 sine of r. So we can write here that our square root of 2 sine of 60 is equal to square root of 3 and sine of r. And from here you can easily see that our r will be equal to 45, and we need to find out the difference between the angle of refraction and angle of incidence. So we can see the difference is our I minus r, that is 60 minus 45 is equal to 15 degree. So this is our 15. Next question. We are given the light enters from air into a given medium at an angle of 45 degree with the interference of air medium surface. After refraction, the light ray is deviated through an angle of 15 from its original direction. The refractive index of the medium is. So here we are given the deviation. Okay. And we are given that it enters at angle of 45 degree. So let us draw an approximate figure. So this is our air, and this is our medium, and light enters from the air at an angle of 45, and it will be refracted in this direction. Let us suppose this refraction angle is given as r, and we get that the deviation is given as 45. So the angle of deviation will be our 15, not 45, sorry. Okay. So from here, so if this is 45, so we can easily see that this angle will be our also 45, and therefore this entire angle will be also 45. So we can see that our deviation that is our d will be equal to our, you can say, I minus r. So we get our 15 is equal to 45 minus r. So this gives us that our r is equal to 45 minus 15, giving us value of r is equal to 30. And we need to find out the refractive index. Okay, so let us call this as mu1 and this as mu2. So we can use Snell's law. Let us suppose this is our O. So we can say Snell's law at O, giving us mu1 sine of I is equal to mu2 sine of r, and mu1 is our 1 sine of 45 divided by sine of 30 is equal to mu2. Sine of 45 is square root of 1 upon square root of 2, sine 30 is 1 by 2. So this gives us mu2 is equal to 1 upon square root of 2, sine 30 is 1 by 2, and multiply by 2 by 1. And we can just rationalize it, and this gives us square root of 2 is equal to 1.414. So option number C is the correct one. Option C is correct. So I think this completes the question. Yes. So this completes the second part from the year 2022, and in second part we completed questions that were inclusive of all the mains questions, and the total number of questions were 25. So this completes the entire, you can say, part 1 as well as part 2. This completes all the questions. Thank you.